Hello friends, hope you all are doing good. We are going to do problem 2 from your packet together here. I thought problem 1 was pretty straightforward, especially since there's no sort of like word problem attached to it. So I thought I would do problem 2 with you, kind of give you a feel for maybe a more medium level difficulty. All right, so this is problem 3 from the 2013 exam, so it would not have been calculator active. Let's read it together. It says, hot water is dripping through a coffee maker, filling a large cup with coffee. The amount of coffee in the cup at time t between 0 and 6 is given by a differentiable function c, where t is measured in minutes. Selected values of c of t, measured in ounces, are given in the table above. All right, in part A, well, actually, before we do part A, let's take a look at really the stem of the problem, make sure we totally understand what the table is giving. So t is in minutes from 0 to 6, and c is, again, if you have this on paper, you do want to underline this, the amount of coffee in the cup. All right, so at any given time, we know how many ounces of coffee are in the cup at that time if t is an integer between 0 and 6. All right, so part A, use the data in the table to approximate c prime of 3.5. Use the computations that show the computations that lead to your answer and indicate units of measure. And I'm actually going to take this a step further and also explain the meaning in context, because you'll see that in some of the other problems coming up, and I want you to really kind of keep that template that I gave you earlier in mind, and practice that, okay? All right, so it's very, very typical for part A of a table problem to be just slope between 2 points, and that's what we've got here, right? If I want to approximate a derivative is the slope of the tangent line, so at one point, I can approximate it going around 3.5, so I would choose 3 and 4, so I'm going to go c prime of 3.5 is approximately c of 4 minus c of 3 all over 4 minus 3. I cannot leave it there because I don't have only numbers yet. So 12.8 minus 11.2, I'm grabbing these numbers from the table, all over 1 essentially. We could leave it like that, simplify to 1.6. All right, let's talk about units. These numbers came from this row, which was in ounces. So, and then these numbers came from this row, which was in minutes. So I'm going to have ounces over minutes. Okay, and that's all that the problem asked you to do. Remember, it's really important that you show the difference quotient as well as a numeric answer. So if you left it like this, that would have gotten you the points there. Okay, but we do need to see a difference and a quotient, alrighty? And then this one also asked for units. Now, again, I'm taking it a step further than what they asked for, and I'm also going to explain the meaning of our answer in the context of the problem. So following our template, we'll say at t equals 3.5 minutes, and then I'm going to state what I underlined there, the amount of coffee in the cup is, and this will be increasing because my derivative was positive, at an approximate rate 1.6 ounces per minute. Okay, again, the problem did not ask for that this time, but it's not uncommon for them to ask for that, so I did want to go over that. Okay, part B, is there a time t for t between 2 and 4 at which c prime of t is 2? Justify. Okay, well, if I'm looking at c prime, if I'm trying to justify that the derivative exists, is that going to be mvt or ivt? This is going to be mvt. Okay, and the conditions for MVT are both continuous and differentiable. Do we know that? Yes, they told us C was differentiable, so it must also be continuous, right? Okay, So let's take a look. Remember the math, the conclusion of MBT is just basically slope, right? F of B minus F of A equals B minus, F of B minus F of A all over B minus A needs to equal the derivative at some point, okay? So let's take a look at that. We're going from 2 to 4, so I want to check the slope from 2 to 4. And it looks like I am going to have rise of 4, run of 2. So 4 over 2 is indeed 2. It is going to check out for me. Now, if it didn't, you can check any interval within 2 to 4. Okay, so if that didn't work, I could check 2 to 3 or 3 to 4 as well. Okay, so any subinterval within there we're also allowed to check, okay, and should if the first one doesn't work. All right, so yes, by what theorem? MBT, mean value theorem. We do need to state the conditions of MBT. So since C is differentiable, C is continuous, and now we're going to show the math. So C of 4 minus C of 2 all over 4 minus 2 was 12.8 minus 8.8, which is 4 over 2, which is indeed 2. So it works. Okay, so 3 pieces there. Make sure you state the theorem, the conditions of the theorem, and then show the math. All right, let's move on to part C. Part C, use a midpoint sum with 3 subintervals of equal length indicated by the data in the table to approximate the value of 1/6 integral from 0 to 6c of t dt. Using correct units, explain the meaning of 1/6 integral from 0 to 6c of t dt in the context of the problem. Okay, it's kind of 2 parts. First, we're going to do just the pure math of it, and then we're going to explain the meaning. First of all, let's take a look at what they're asking us to find. Does that formula look familiar? Does it look like this? Right? Which was average value of f on the interval a to b. So this is going to give us the average value of c, and remember c gave us the amount of coffee in the cup from 0 to 6 minutes. So that is what the second part is. That's going to essentially be the explanation, okay? Now we want to use a midpoint sum using 3 subintervals of equal length, okay? Now, what happens oftentimes is students see midpoint sum and they're like, oh yes, I know how to do midpoint, LRAM, RRAM, trapezoid, and they just go for it, okay? That'll get you a point, but it's not going to get you full points here because look, you've got that 1/6, right? And the midpoint sum is just approximating the integral. You still have the 1/6, okay? So here's what we're going to do. We're going to have 1/6 integral from 0 to 6 of c of t dt. This is going to be approximately 1/6, and now I'm going to open up brackets and put MRAM inside those brackets, okay? So we want 3 subintervals of equal length, so that means we'd be going from 0 to 2, 2 to 4, and 4 to 6. So each base is going to have a length of 2. Now, your height depends on what method you're using. In this case, they want us to use MRAM. So my first height is going to be the middle y value in that subinterval. So base of 2, height of 5.3, plus, second one has a base of 2, height of 11.2, plus, and the last one has also a base of 2, this time height of 13.8. Okay, and I would leave my approximation like that. Oftentimes if you leave it, and you did it correctly, you're automatically going to get 2 points, because sometimes they give you, they give you a point for the approximation and a point for the answer. Well, if you didn't bother simplifying, you automatically have that answer point as well. So please don't simplify, okay? I know you're going to have an access to a calculator for all the problems this year, but it takes up time for one, and it's still easy to accidentally type something in inaccurately. So please just leave it, okay? All right, now let's go for the second part. Using correct units, explain the meaning of that integral. in the context of the problem. All right, so we said this gives the average, and now we're going to go back to those words we underlined at the very beginning, right? Amount of coffee in the cup. Okay, amount. This gives the average amount of coffee in the cup, and they wanted units, in ounces, from t equals 0 to t equals 6 minutes. Okay, always make sure you've got 2 units, one for your independent and then variable, and then one for your answer as well. Okay, so that is that. All right, part D, the amount of coffee in the cup in ounces is modeled by B of t, which is given by 16 minus 16e to the negative 0.4t. Using this model, find the rate at which the amount of coffee in the cup is changing when t equals 5. Well, rate, instantaneous rate, is what? It's the derivative, right? All right, so our goal here is to find b prime of 5. So let's first find b prime of t. So derivative of that first term's a constant, it goes away. And then let's take a look at the second term. Looks like I need chain rule, right? So that negative 16 comes with us. And then the derivative of e to the negative 0.4t is going to be e to the negative 0.4t times negative 0.4. I'm going to bring it to the front. Okay, so there's b prime of t. So final answer, just plugging in 5 for t. I've got a negative times a negative, so if you want, let's just make that a positive. All right, and that is that. And I would just leave it like that. Okay, all right, that is problem 2 for you. This packet only has 5 problems plus the example, so if you've copied the example and done problem 2 with me at this point, go back and do problem 1. If you're doing this on our timeline, this would be on a Friday, and then you can do problems 3, 4, and 5 on Monday. Okay? All right, keep messaging me any questions you have. Please don't ever feel like you need to wait for a certain time if I can't get to it right away. I'll get to it when I can. So it is never a problem to send me a message via remind any point in the day, okay? I love to hear from you all. I love to see your names pop up on the screen. So send me your questions, and I will see you for our Zoom chat soon. Bye, y'all.